Whoa, my fellow geothermal students. Greetings once again, Jonathan Bowe here. And here's our topic 6 already. So hope you guys, more of you are going to get in there and take a look at that quiz from last week. Week 5, smart geothermal questions in regards to your reading. This will be a quiz over your reading assignment in week 4, Smart Guide to Geothermal. This is the good stuff. 10 questions, 1 attempt, 60 minutes. Make sure you've read through the first 5 chapters of the Smart Guide to Geothermal. Please do well, and remember, always choose the best answer. So not to be tricky, but sometimes it's all of the above. You know, there might be 3 correct answers, and the best answer is all of the above. So don't get fooled by that one. We've got some really good stuff today, though. The Pacific Rim, Ring of Fire. What is that all about, man? Let's take a look at this guy. If you haven't figured it out yet, I like volcanoes and the Pacific Ring of Fire. Well, we're going to find out about volcanoes and the relationship of the Pacific Ring of Fire to the type of eruptions that are the type of cones that are formed. Yeah, Pacific Ring of Fire. So some things to watch for now. The type of cones, the volcanoes tend to be larger, taller in stature, and the eruptions tend to be more violent, shorter duration, and the lava tends to be more viscous. So let's take a look and see.
Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving behind a trail of geological mysteries. One of Earth's most intriguing mysteries is the presence of a huge arc of geological destruction surrounding the Pacific. It is known as the Ring of Fire. 3/4 of Earth's volcanoes are situated here, and 90% of all earthquakes also occur along this line. Over the last 200 years, disasters here have claimed over 1 million lives. Now, scientists set out to discover why these volcanoes and quakes occur all around the margins of the Pacific Ocean, and to find out what powers them. Unlocking the mysteries of this awesome force of geology will bring the scientists one step closer to understanding how the Earth was made. Ring of Fire is one of the most extensive zones of destruction on planet Earth. Its most visible features are the hundreds of volcanoes that line the shores of the Pacific Ocean. They form an arc which extends 25,000 miles from South America along America's northwest coast to Alaska, and then down through Russia, Japan, and Southeast Asia, all the way to New Zealand. Cataclysmic eruptions have occurred here throughout history. August 1883, Indonesia. The Krakatoa volcano blew itself to pieces, creating the loudest sound in recorded history. June 1991, the Philippines. Mount Pinatubo blasted debris 22 miles into the atmosphere. Suffocating ash swamped over 2,500 square miles. And in May 1980, Mount St. Helens caused $1 billion of damage.
So we want to take a look here at the Mount St. Helens, the way this is releasing here on the northeastern face, how this whole the largest landslide recorded in modern history, as far as we know. And the stresses that we talked about in topic 5, that are showing up in the Bighorn area. This is just a larger scale of that same type of manifestation of bulging. Rather than having it be a earthquake activity, it's the underlying magma actually pressuring in from underneath and causing it to expand or to bulge.
The ever-present threat from these volcanoes makes it essential for scientists to understand the forces that power them. The investigation begins here, in Alaska. This land of rugged beauty marks the most northern extreme of the Ring of Fire. 75% of all the volcanoes in the United States are situated in Alaska, making it a perfect laboratory for volcanologists. The first step is to discover how the Ring of Fire's giant volcanoes form.
We're headed to Augustine Volcano, which lies in Cook Inlet, and it's part of the chain of volcanoes that extends all the way down into the Aleutian Islands.
It's a 60-mile journey out across the frigid Alaskan water. In the distance, the volcano soon appears.
There's the Augustine Volcano over there. It's going to be a perfect day to visit.
From high above the clouds, Dr. Bull can gain a clear view of the volcano's distinctive outline. Augustine is a stratovolcano, the type of volcano found all around the Ring of Fire.
So stratovolcano is an important term you want to remember, particular or peculiar to the Ring of Fire.
Volcanoes are quite unique in that they are shaped as beautiful cones, and Augustine is a perfect example of that.
Augustine last exploded in January 2006, the most recent of 7 eruptions here since 1935.
See the same type of sagging that went on with St. Helens at a smaller level here, and a lot of that snow. But what's important is that you see the difference or the contrast between these types of volcanoes here and the volcanoes in Iceland. Smaller in stature, not as violent, longer duration in the eruptions.
Over the years, solidified lava flows have gradually built up on the volcano's flanks. To investigate what makes these volcanoes so dangerous, Dr. Bull climbs high up on the side of one of these lava flows.
This lava is made up of blocks. There's bits that are a little denser than others, and you can see there's a lot of different pieces to it. So we call this a blocky lava flow.
This blocky lava provides a crucial clue as to why the Ring of Fire volcanoes can be so deadly.
This lava is more thick when it comes out of the volcano, and its thickness will have an effect on how it runs down the slope. The thickness or viscosity of lavas can be shown in a number of ways. Hawaii lavas are quite runny. Honey is a perfect example of that. If you have the volcano putting out Hawaii-like lava, it's going to run quite easily down the rock. Whereas if you have something more like these blocky lavas, they're going to be a little bit more like peanut butter. They'll still run, but the viscosity is much greater.
The viscosity of lava is primarily determined by the amount of silica it contains. Silica is the most abundant mineral in Earth's crust.
The more silica, the thicker or more viscous a lava is likely.
The more silica, the thicker the lava is. Important point.
To be.
Hawaiian lava contains little silica, so it's runny and produces a relatively flat landscape. But Ring of Fire lavas are rich in silica, making them sticky and less able to flow, creating tall, cone-shaped stratovolcanoes. During the 2006 eruption of Augustine, thermal imaging cameras were used to study the volcano. They showed this sticky lava building up layer upon layer. But the thickness of this lava also makes these volcanoes lethal.
Because these volcanoes have lava that is thick, things don't move through them very well. And bubbles of gases can build up.
Deep in the earth, under immense pressure, molten rock called magma contains dissolved gas. But as this magma rises, the pressure decreases. This drop in pressure means bubbles of the gas begin to appear, just like opening a bottle of soda. If the magma is runny, these gases can safely escape. But in sticky, silica-rich Ring of Fire magma, the gases can get trapped, often with terrible consequences.
It's like trying to have a bubble move through peanut butter. It won't happen quite so easily. So there's a lot of pressure that builds up. And once that pressure builds up, it reaches a point where it can't take all that pressure anymore.
The result? Giant explosions caused by the catastrophic buildup of gas inside the molten rock.
And this is what they theorize is the potential in Yellowstone, is that the type of volcano that it is, if it does go catastrophic, there will be an explosion. But you saw where it tends to branch out under the cap and can relieve sequentially or less violently. And the Yellowstone volcano is not quite, it's kind of an oddball. It's not really on the Ring of Fire. It's slightly outside the Ring of Fire.
This is the reason Ring of Fire volcanoes can be so dangerous. But it's not usually the initial explosion that kills. It's what happens next.
Those explosive eruptions can create plumes that go up for tens of miles.
When these plumes run out of energy, they can collapse back down the sides of the volcano in a superheated avalanche of ash and gas. With temperatures of 1,300 degrees Fahrenheit and speeds over 100 miles per hour, these flows destroy everything in their path. A terrifying consequence of the explosive eruptions caused by gases building up inside thick lava. In the next stage of her investigation, Dr. Bull searches for clues as to how this sticky lava forms. On Augustine's lower slopes, she hunts for lava samples from inside the volcano. This giant block of solidified sticky lava was once molten magma deep underground. It was blasted out here during an eruption, and it came with some intriguing evidence.
So what I'm seeing in this rock is a lot of minerals and a little bit in some cases of hornblende.
The presence of these hornblende crystals provides a crucial clue to how the magma formed.
This is important in telling us something about magma conditions where the hornblende crystallized. Hornblende is a mineral that only forms in the presence of water.
These hornblendes show water exists deep in the earth. Scientists suspect this water plays a crucial role in creating the magma that powers volcanoes. Deep underground, rocks are hot and semi-solid. It might seem that the presence of water would cool them down. But that's not what happens. This water, which is under huge pressure, alters the rock's structure and causes them to melt, forming plumes of magma. This molten rock soars up to the surface, building giant volcanoes. Without water causing magma formation deep underground, these Ring of Fire volcanoes would simply not exist.
A lot of this process we're still working on and we don't understand, but there's a fair amount of it that we do. And water has a very significant role in when and how rocks melt.
The investigation into why the Ring of Fire is so dangerous has uncovered two important pieces of evidence. Blocky lava flows are evidence of thick, viscous magma which traps gases inside volcanoes, leading to explosive eruptions. And hornblende crystals reveal that water deep underground encourages the formation of the magma that powers the volcanoes.
So you remember from our earlier lectures, I think it was back in topic 4, that as the tectonic interface, as the suboceanic plate subducts and goes under the continental plate, it carries in the crustal portions. Seawater is trapped in there. It's like a big sponge kind of, and that's where this water, that's where they theorize that some of this water comes from.
The geology detectives figure out how this water gets underground and make a remarkable discovery: the chemical signature of microscopic organisms inside the volcanoes. All around the Ring of Fire, explosive magma is forming deep underground, fueled by water. Solving the mystery of where this water comes from is the key to how scientists will figure out why the Ring of Fire is so dangerous. The investigation now turns to Mount Lassen, an active volcano in Northern California. Surrounding the volcano are bubbling hot springs, boiling mud, and volcanic vents called fumaroles, belching superheated steam and gas. All this thermal activity is driven by the immense heat rising from magma deep underground. By sampling the gas coming from these fumaroles, scientists hope to discover the source of the water which causes the magma to form.
This device measures temperature. The temperature of this fumarole is 92.5 degrees C, about 200 degrees Fahrenheit. So just about at the boiling point for this elevation. And that's what we want for a good gas sample, a good boiling fumarole. So you can see what's happening at the surface here, all the steam coming out of the ground, but it's the gases that are along with this steam that we look at closely. And the composition of those gases tell us about what's happening at various depths beneath the ground where we can't see.
Tests on these gases, collected from volcanoes all around the Pacific Ring of Fire, have revealed something surprising. The gases contain carbon-12, a type of carbon that comes from living organisms. The specific levels of C12 found here are the unique signature of tiny sea organisms called phytoplankton. Billions of phytoplankton live in the ocean. As they grow, they absorb carbon-12 into their cells. When they die, they fall to the bottom, forming layers of sediment. In this way, their carbon-12 is transferred to the seafloor. Intriguingly, scientists have found this same carbon-12 pouring out of volcanoes all around the Ring of Fire.
Volcanoes of the Cascade Range have carbon dioxide that's very rich in carbon-12, and it's almost like you're cooking oceanic sediments that are rich in phytoplankton down deep beneath these volcanoes to generate the carbon dioxide you see coming out the top. That links this carbon dioxide to organic sediments way offshore in the ocean. The organic matter that was originally phytoplankton becomes carbon dioxide that we see at the surface.
Seafloor sediments are getting into volcanoes, and these sediments contain seawater. This is the water that causes the rocks to melt below the volcanoes, forming magma. But a mystery remains. The magma plumes feeding the volcanoes lie sometimes hundreds of miles from the ocean. The scientists now have to figure out how the sediments loaded with seawater are moving so far inland. To find out, the investigation heads for Alaska's Chugach Mountains. The research here begins with an analysis of the local rocks.
Oh, this is a really neat boulder that's right here. And what you can see in it is that there's this whole mixture of rock types. You can see that there's this black stuff, which would originally been mud. There's several different colors of kind of greenish rocks, which would be kind of different flavors of volcanics. So here it looks like there's limestone. And I'm going to put some acid here, and if it fizzes, it's limestone. Yep, sure enough, that's what it is. And this would have formed in the ocean. And so this is made up of the bodies of little critters. It got incorporated into this rock, and now it's up here in the Chugach Mountains.
The presence of jumbled oceanic rocks 20 miles from the sea is evidence that something remarkable is happening at the bottom of the ocean.
The fact that you have this mixture of rock types here is evidence for the seafloor moving.
Geologists know that only an enormous process called subduction could shift these mixed ocean sediments here. Subduction occurs when the seafloor moves and slides down under the land. As it descends, the top sediment layers are scraped off by the land like a snowplow scoops up snow.
So subduction occurring there could be the California coast. And interesting how these coastal ranges are formed. Like he's talking about, there's like a snowplow when it scrapes off softer materials, and then you get these wrinkles here.
They're pushed up into a huge mound of mixed up rocks. The Chugach Mountains were formed in this. This is how seawater gets deep underground, where it creates the magma plumes that build the Ring of Fire's explosive volcanoes.
Where we're at right now, the Pacific is subducting beneath us to the northwest at this northern part of the Ring of Fire. It's about 20 miles beneath our feet right here, but if we were to go off that way where the volcanoes are, it's about 60 miles beneath our feet there. And so as it goes to the northwest, it subducts and then brings water and sediment into the earth. That ends up causing melting in the mantle, and then that melt rises as magma to volcanoes.
The investigation to discover how water is getting down below Ring of Fire volcanoes has turned up intriguing clues. Carbon-12 samples indicating that ocean sediments are getting deep below the Ring of Fire's volcanoes. And mixed rocks in the Chugach Mountains, 20 miles inland from the ocean, are evidence that the whole seafloor is on the move, sliding deep under the land. This process is the engine that powers the Ring of Fire's killer volcanoes. But deep underground, the Ring of Fire hides another, even more deadly secret. Earthquakes that can destroy entire cities. The Ring of Fire, a lethal line of volcanoes. 75% of all the volcanoes on the planet. These fiery peaks encircling the Pacific Ocean are built by tremendous forces deep in the earth. Eruptions here have taken many thousands of lives and destroyed billions of dollars of property. But an even bigger killer is present on the Ring of Fire. Earthquakes.
So this doesn't fully explain the Yellowstone phenomena. The theory is that Yellowstone is just on a different scale, so that it's not just plate tectonics. There's a magma plume that they haven't really determined the full extent of, but it's coming right up out of the mantle, whereas this, you know, it's associated with crustal plate tectonics towards the top, but the earthquakes also. So let's take a look at the earthquake aspect here. Let's